Today we're going to talk about some of the advantages of a system that is called VAV. It's variable air volume, and we will talk about the applications as to the advantages, where to use a VAV, and the pluses and minuses, or the pros and cons of each type system. VAV stands for variable air volume. It is another spin-off or a graduated form of a packaged rooftop unit. It is a system that continually provides 54 or 55 degree air through a medium pressure supply trunk line. This 54 or 55 degree air feeds what we call fan terminal units, more commonly referred to in our industry as FTUs, and the FTUs provide heating and cooling to the exterior zones. We use those on perimeter zones, and then the interior zones, that 54, 55 degree air is providing air to VAV boxes, which are variable air volume boxes. These boxes are smaller. They do not have fans in them. They do have electric heaters, so that as we have to continually meet code requirements, the electric heat can temper that air, and so that we do not overcool and provide drafty spaces for our occupants. That are one of the advantages of a VAV system is we can heat and cool different areas in the building at the same time, which is not possible with any other constant volume system or a constant volume with a VVT system. So it's unique in the industry. Some of the advantages of the VAV system are its efficiency. When we run a load and design a building, we can take a diversity. As you know, the sun rises in the east and sets in the west. So we have a bigger load on the east side of a building in the morning, and we don't have that sun load in the western side of a building. So we can take it a diversity, and that diversity means we can get by and design around smaller tonnage units. If you have a constant volume rooftop unit, you have to design for the maximum load for every instance or every case for every unit. We shift the air conditioning capabilities to match the load. It's more like a load matching type system. Along with the less tonnage, we pick up on the efficiency. We have less horsepower, because when we have areas with no load condition or low load condition, the fans are controlled by variable frequency drives, or we call them VFDs. And those the VFD basically runs the RPM of a motor up and down. It basically just it matches the fan load, or what we need to distribute that air to those zones calling for cooling. With lower horsepower and using less RPMs, we have a more efficient system. We don't draw as many kWs on the motor side. The VAV systems they provide you zone control, and they also provide you with better dehumidification. We don't have the humidity issues with VAV, because again, we're load matched. We can offload or down, reduce our capacities and shed some of the load on these rooftop units. When we get into two-story office buildings, a VAV system provides you more, or provides the owner more usable space on the second floor, because we don't have all the supply and return shafts to go from the roof down through the second floor to the first floor. So it gives you more usable space. As far as sheet metal costs, when we do a VAV system, we have motors, more high efficient motors that can move air faster. We design most of our medium pressure ductwork at 2,500 to 2,700 feet per minute. And we design our supply ductwork for constant volume rooftop units at no more than 1,500 feet per minute. What that means is we can get by with smaller ductwork, so you have less pounds of sheet metal, and it's usually easier to install and goes up in bigger sections, which in the end saves you money. The VAV system is controlled by an energy management system or a building automation system, which we call a BAS. And one of the advantages, again, of the BAS is if you need to check on a building, you can check and see what's going on in that building from a remote location. You can call it up on a laptop, you can make changes, you can lower temperatures in different zones, you can raise temperatures in different zones. And another thing the BAS you can do, or one of the options of the BAS, is if you, in the future or down the road, if you have issues with a zone or some not cooling properly or not heating properly, you can pick that up, and through the graphics package, you can do self-diagnostic work and find out if a motor has gone bad on a fan terminal unit. So it will save your service costs with your local service company. So those are some of the advantages of the VAV system. The sweet spot of a VAV unit is buildings or offices that are in the 10,000 to 12,000 square foot range and greater. Once you get below 10,000 square feet, the VAV tends to be a little cost prohibitive. But again, 10 to 12,000 feet and larger, that's your sweet spot or your best place to incorporate a VAV. The disadvantages of VAV, they're depending upon what your budget is for HVAC. The VAV systems are the most or most expensive cost per square foot. But to me, that is that and the size of the units, because we usually have bigger units. 25, 30 tons are usually the smallest. They go up to 150 tons. So, in designing a building, you have to design around the structure, and sometimes that can add some additional costs. From a standpoint of, the electrical costs of a VAV system, the electrician has to run power to feed all of the fan terminals and VAVs, which could be an additional expense over and above that you don't have with a constant volume rooftop. But those are basically the pros and cons of a VAV system.